Hi, I'm Fernando Pereira from UFMG, and today we continue talking about tainted flow analysis. However, before we dive into the actual implementation of the analysis, we shall define a toy programming language. We will use this toy language to explain how the different analyses that we shall see work. To recap, we need to find a path within the program from a source of information that an adversary can control until a sensitive site that uses this information. And this path must not go across any sanitizer. But what is actually a path within a program? We can consider two different definitions of paths, and both work for our analysis. First, a path can be defined by the chain of dependencies between variables in the program. But a path can also be a sequence of basic blocks in the Contraflow graph of the program. And to explain how our analysis works, we shall define this toy language. We will define our analysis on top of this language using its instructions. But you will be able to guess how the analysis can be extended to a complete programming language. The thing is that having the toy language helps to explain the essential components of the analysis instead of having to deal with minutiae of syntax of actual mainstream programming languages. Here's our toy language. It contains 6 kinds of instructions. We will go over all these instruction types. The first instruction is an assignment from source. You can see its syntax here. We have this white circle on the right side, and then we have a variable that's defined on the left side. You can see a high-level example of usage on the left, and the low-level representation of this program on the right. So we shall be using this high-level program to illustrate how the syntax works, and then we'll be showing how it appears in the low-level representation. That's our toy language. Then we have filters. Filters are like assignments, but we know that they will always produce clean information. You can see examples in this figure. And we have validators. A validator is like a conditional that tests some information and determines if this information is clean or tainted. We have branches as well. These are very abstract kinds of branches. You see, they have a number of labels that you can see here. A number of labels actually. There is no condition. The branches are used just to create the Contraflow graph. We will need that to explain the different implementations of tainted flow analysis. Notice that because we do not have conditionals, our language is not really executable. Again, its goal is just to give us all the notation that we need to define our analysis. We have also assignments to sync. Syncs, again, are the sensitive sites in the program that we need to protect against tainted information. And we have simple assignments. We use this special circle with an X right here to mean any operation. We don't care. We have assignments in our toy language just to be able to represent data dependencies. We mentioned that there are 2 ways to define paths in a program. Well, there are more actually, but in this class we shall be concerned only with these 2 ways. So in our first definition, a path is a sequence of instructions in a Contraflow graph. Let's see this notion with an example. We shall be studying this program on the top. Here's the Contraflow graph of the program. Notice that we have many paths within this graph. To ease our presentation, we are not grouping instructions in basic blocks, so each instruction is like its own basic block. Well, that's not really the definition of basic blocks if you remember. But just imagine that each instruction stands alone in the CFG. That will simplify the representation of the analysis. Anyways, can you check if this program is vulnerable or not? Is there any path from sink to source where bad information can flow without going across a sanitizer? You might stop the video and try to answer this question. Here's the vulnerable path. You see, we can initialize V with an input that the adversary controls in label L, L0, and then we can use V in label L7. There is a sanitizer on the way though. So is this program really vulnerable? Well, in the next class we shall see how to check that. So the mission will be to identify tainted flows in the program. You can think about this algorithm before I present it. In the next class, we shall see a dense implementation of a tainted flow analysis. Until there, you feel free to write me with questions or comments. Thank you.